Hello everyone. Today we are going to explore the fundamentals of IoT and system architecture. By the end of this session, you will understand what IoT is, how it's structured, what technologies power it, and where it's changing the real world. So, what is IoT? IoT stands for Internet of Things. The simple idea is of connecting physical objects to the internet so they can collect and share data. Think of it as giving everyday objects a digital brain. A thermometer becomes smart when it can report temperature to your phone. The three pillars of IoT are things, the physical devices, internet, the connectivity, and the data exchange, the communication between them. And there is a prediction that by 2030, over 75 billion devices will be connected worldwide. Key characteristics of IoT. IoT devices are IoT devices share six key characteristics. First is connectivity. They must be able to communicate wirelessly. Second, sensing. They perceive real world conditions like temperature, motion, or light. Third is intelligence. They process data locally or send it to the cloud for AI driven decisions. Fourth, security, which is a critical one. All the data must be protected. Fifth, interoperability means different brands and protocols must work together. And finally, actuation. IoT doesn't just observe, it acts. A smart thermostat doesn't just read a temperature, it adjusts automatically. Coming to the evolution of IoT. How has IoT evolved itself? So, IoT didn't appear overnight. It began in 1982 when Mellon University connected a soda machine to the internet to check if it was stopped. Then in 1999, Kevin Ashton coined the term Internet of Things. By 2008, the number of connected devices exceeded the world's human population. The consumer IoT exploded in 2014 with smart speakers and wearables. Today, 5G and Edge AI are pushing the IoT into entirely new frontiers. Coming to the scope and applications of IoT. IoT touches every major industry. Smart cities use IoT for traffic management, smart lighting, and waste collections. Healthcare IoT enables Healthcare IoT enables remote patient monitoring and wearable diagnostic. Industry 4.0 uses IoT for predictive maintenance in factories. Smart houses automate comfort and energy efficiencies. Agriculture IoT optimizes irrigation and soil health. Energy IoT powers smart grids and demand response system. The scope is truly global and immense. Coming to the comparison of IoT versus traditional embedded systems. Traditional embedded systems are isolated, fixed functions, a microwave controller, a washing machine timer. They cannot update remotely. They don't connect to internet and they can't share data. IoT systems, on the other hand, are internet connected, cloud enabled, scalable, and updatable over the air. The key upgrade, intelligence and connectivity layered on top of physical hardware. This makes IoT system better than the traditional embedded systems. Coming to the architecture of IoT, how exactly the IoT works? IoT architecture describes how data flows from physical devices to users. There are four functional layers. The perception layer collects raw data via sensors. The network layer transmits the data wirelessly. The middleware layer processes, stores, and analyzes the data. All the data processing process, such as cleaning data and removing the null values and removing the duplicates, all these things come under the middleware layer. And at the end comes the application layer, which delivers insights and services to users such as the dashboards, alerts, and the control systems. Think of it as a pipeline. Think of it as a pipeline of transmit, process, and act. Coming to the other architecture of IoT, which is a three-layer architecture. This three-layer model is the simplest and the most cited model. First is the perception layer. The physical sensors sensing the environment. Network layer, transmitting data via internet or local networks. Application layer, where end users interact with the dashboards and services. This is a clean conceptual model. However, its limitation is that it doesn't explicitly address how data is processed or stored in the middle, which leads us to a four-layer model. So the four-layer improved model is four-layer model adds a crucial processing middleware layer between the network and applications layer. This was the improvement made from the third layer, three-layer model. So this layer, which is the middleware layer, handles the data aggregation, cloud storage, database management, and real-time analytics. Let's try to understand it with an example. In a smart factory, sensors detect machine vibrations, which is the perception, and the data travels over 5G, which is the transport, and cloud runs predictive algorithms, which comes the processing part. And engineers receive an alert on their app, which is the application part. So this model accurately represents an IoT, how exactly the IoT architecture works. And this was how the four-layer architecture works. Coming to the IoT ecosystem. So the components of IoT. The full IoT ecosystem has six essential components. Sensors, sensors and actuators interact with the physical world. Edge devices like Raspberry Pi process data locally. Gateways bridge different protocols. Cloud platforms like AWS IoT provide scalable infrastructure. Databases store time series sensor data. Analytics engine extract actionable insights using machine learning. Remove any one component. If you remove any one component, the system breaks. So all the six components are dependent on each other and equally important for any IoT system. Coming to enabling technologies for IoT. So there are three main technologies to make large-scale IoT possible. First is the wireless sensor networks. Low power self-organizing networks of tiny sensor nodes using standards like IEEE 802.15.4. Cloud computing platforms like AWS Azure or GCP Elastic Storage, and compute for billions of IoT data points. Big data and analytics. Tools like Apache Kafka and InfluxDB process massive data streams in real time, and machine learning models turn raw sensor readings into predictive insights. Coming to the important part, which is the IoT protocols. IoT uses specialized protocols designed for constrained devices and unreliable networks. First is the MQTT. It is the most widely used, a lightweight publish subscribe protocol, perfect for sensor sending data to cloud brokers. Next is the COAP, is like HTTP simplified for microcontrollers. And at the network level, ZigBee creates low power mesh networks for smart homes. And coming to LoRaWAN enables kilometer range communication on a tiny battery used in agriculture and smart cities. And the last one, which is BLE, which is Bluetooth Low Energy, powers fitness trackers and medical wearables and all the other smart devices. So protocol choice depends on range, power budget, and the bandwidth needed for a particular device. Coming to the communication models. So IoT uses four communication patterns: device to device, uh, uh, talk directly like a Zigbee light switch controlling bulb, or device to cloud, a sensor sends data directly to AWS or Azure, used in remote monitoring, or device to gateway. Devices connect to a local hub which aggregates and forwards data, common in smart factories. And back-end data sharing. Cloud services exchange data via APIs, enabling cross-organizational analytics like hospital IoT data feeding medical platforms. Most real IoT systems combine all these models multiply. Coming to a real life application. So let's look at two concrete domains. One is the smart city and other is the healthcare. So Barcelona approximately saves 37 million uh, pounds per year using IoT smart street lighting. Uh, Sensors manage the traffic signals dynamically, reducing the congestion by up to 25%. Wind send alert only when full, cutting waste collection trips. And in healthcare, as you know, the Apple's Watch, the ECG feature has detected, has helped in good results in detecting ECG levels of humans, and remote patient monitoring reduces the hospital redemptions by up to 38%. IoT enabled smart beds detect patient falls before they happen. These are not just future technologies, they are even operational today. So coming to the end, uh, let's conclude this introduction to IoT. So to summarize, IoT is a network of connected physical devices that sense, communicate, and act. It has six key characteristics: three-layer and four-layer architecture model, and it's powered by WSNs, cloud computing, and big data. Key protocols include MQTT, COAP, Zigbee, and LoRaWAN. And it's already transforming smart cities, healthcare, and other industries like agriculture and many more. So this was it for today's lecture. Thank you.